All right, welcome to the In the Loop podcast. To Mike Antosh here. I've got Ted Docherty with me and Grace Ung. And we did a podcast number 8, which was about P&IDs. Then in the second half of that, smart P&IDs. And we started some good topics there. We talked about the fundamental purpose of those documents in the industry and a little bit of the journey about making them intelligent. And and then toward the end, we started talking a little bit about where does that move it to the future, and how does that potentially apply from an AI perspective. We mentioned the term graph database or graph depiction of a P&ID. And today the purpose is to follow up on that, kind of pick up that conversation a little bit and actually show a little bit of development from the graph visualization of a P&ID database. So the roles that we've had in sort of putting this together for our team is, Ted, you serve as a subject matter expert from a smart P&ID perspective, sort of an administrator of P&ID products and database analyst. Is that fair?
Yep, that's right.
Code writer in some instances. Of automation. I just did a podcast last week with Brian Bailey, and we were defining the personas of the people in an automation department. But in that sense, we were talking automation of a facility. So control valves, control loops, all that sort of stuff. But in this term, automation is a term used in terms of automating the drawings, automating the data entry, right?
Yeah, data entry, placing symbols in the drawings, things like that.
So if we looked at the Octave Smart P&ID product, there's a particular, there are a few DLLs that you can use. What are those guys?
Yeah, it comes with a couple delivered libraries. There's they call it Llama, is the one for editing data, pulling data out and pushing it back in. They have one called Place for placing symbols.
Okay. Yeah, I particularly wanted just to draw llama out.
Okay.
For some reason.
Your spirit.
I got to let everybody know that's chiming into this that we really know about that llama DLL.
That's right. It's there. We know about it.
It has nothing to do with the llama books, but you're right. It's there. We know about it, right? Okay, so that's your perspective. Right, we can't talk automation without llama. We'll come back to that in the end. Have you read any of the llama books to your kids?
Red Pajama. We've got Loose Tooth Drama.
Okay, good. So I like it when my references make sense. Like Grace here is younger. You know, we established in the last podcast that I was the elder statesman in the room, and that has not changed now that we've added Grace. Grace, you graduated from Texas A&M when?
In May.
May of 2026. Okay, so this May. Okay, so you're with a degree in what?
Computer science.
Computer science. Okay, so Grace's role in this is to put our ideas, and I'm going to include both of us, Ted, but a lot of Ted's ideas and a few of mine, into an interface to where we can continue to show knowledge and value. And so we actually have had several discussions about, like, what does it take to do engineering and engineering IT and development? And it generally does take some development, programming, computer science knowledge, but that has to be coupled with practical, real-world understanding and perspective. If left alone, the engineer will probably go to Excel and hack something out. And if left alone, the computer science developer alone will probably develop something that's really impressive, but maybe not applicable. No offense. So Grace is relatively new to this, but it's been we've been doing some recent development. We've had progression of this for a while, but we've also ramped up a little bit with what we're doing with the graph, particularly recently, and we wanted to show a little bit of that. Grace, a little bit about yourself. What you're an athlete. What sports do you like to play?
I like to play soccer and basketball.
Okay, great. And
Was that 50% right, Mike?
I don't even know that joke. What am I
You're a
doing?
basketball guy and not a soccer guy.
Oh, yeah. I'm definitely, I agree with half of that. But you are a
I'm
soccer
a soccer guy.
fan,
Yeah.
player, coach, sort of a Ted Lasso of sorts kind of figure,
Yep.
right? Have you guys had any soccer conversations?
A little bit about England soccer because I'm an England soccer fan.
Yeah.
Yeah.
Okay, so you particularly because your family has roots in England,
Yep.
so you do follow that team. Okay,
The
and they
summer
did
was a
pretty
good
well.
summer. Yeah.
Summer was a good summer. Okay, great. Are you a fan of a particular soccer team?
I'm not. I'm a fan of playing soccer instead of
Okay.
watching.
Okay. And also spike ball. You didn't mention spike ball, but I
Yeah.
think you've done some of that, right? Which
Yeah.
I'm having trouble. That's a combination. That's like a volleyball, but for a smaller group on a smaller net. I've tried it. I'm not sure that I've figured it out yet.
Like
So,
the pickleball of volleyball. When you take tennis
Kind
and
of.
shrink it, you shrink in volleyball.
yeah, you shrink it even more though. You
Yes.
shrink it all the way down
like
to
a-
like a mini trampoline.
Yeah.
And so it's a lot, and the ball shrinks a lot.
Yeah.
So it's a little bit, but it's similar, right? Okay, good. I like to establish that all, if we can work some references in to whatever those interests are, that's good. Okay, great. Well, then let's get down to the details of this because we recently have had some conversations like what we alluded to in the previous podcast was, and I have to start this timer. So Danielle, I don't know if I did that like 10 minutes late or whatever, but just to keep me in tune. But we talked about the fact that, all right, if you have a P&ID in the simplest form is a CAD drawing, or maybe a sketch back in the days, but a CAD drawing. And then the concept of a smart P&ID means it has a database behind it, at least in the general description I think people would give. And then there's kind of a question about, okay, that's great. Tell me all the things that you get out of that. And so if I have a smart P&ID system, that means I've got I've got a data structure, I've got generally a graphic symbol catalog, and when I use that product, I have rules that I have to play by. And playing by those rules helps me build a good drawing, helps me generate lists from those drawings and do quality checking. But I've had some people look at me and say, "So what? Like that's pretty good, but is the effort worth that? Like is the juice worth the squeeze, right? Is the result worth it? Because you do have to have an infrastructure and a database and an administrator and knowledge. And so as I've progressed in my career, what I've seen is that you've got a drawing, I create reporting and analysis and I use the rules to get an output from that drawing that finds some issues, feed that back to the team, they'll update the drawing, and I will then have a drawing that's finished, and I'll have deliverable lists from that. But there's more that could be done. However, it's hard for the project to simply justify more precision and more fine-tuning because there wasn't necessarily a receiver for the next level of value. So the more engineering project world, they draw the drawing, they extract the data, they integrate it with other systems. It's a value add, but it's not necessarily a game changer completely where you say, this was unbelievable. And we could have never done it without this. That's not generally the sentiment of the intelligent P&ID. And then so the question is, if there's more value there, what is it? And who is going to recognize that and be able to use it, right? Because if I'm drawing the drawing and I have a line and I drag a valve onto that, well, the valve snaps into the line and it checks to make sure that it's in compliance with the parameters, and it checks the rules, and if it works, it lets me move forward, and that's good. But all of those connections have value. The question is how, right? Who's the person that's going to study that, and who's going to say, hey, I see where that value is. If I can traverse those relationships, and I can deduce what's upstream of an object, what's downstream of an object, how I might isolate that thing. Is it designed consistently with the way that our engineering standards are, in the right order and configuration? Some of those things are hard to do from a pure reporting perspective. I mean, Ted, most of the reporting outputs that you've generated from a smart P&ID are in what form?
They're just lists of objects, so Excel tables, basically, right?
Right. Yeah. So if you have an audit that says, hey, we have a standard that says valves should be configured this way, or they should be designed this way, or PSV configuration should be, you can analyze that and produce a list for someone that says, hey, this scenario here complies with our rules, this one doesn't. But ultimately, then you supply someone a list. And what do they have to do?
They have to go through the list, open the drawing up, check out whatever's going on in that scenario, and figure it out.
Yeah. Do you see any challenges there in terms of getting from your report into action?
Just a lot of steps, I guess. I mean, the reports, depending on what it is, it could be, hundreds of things long, and it's not easy to necessarily understand just looking at a table of data what the problem is. So
yeah,
it takes a lot of manual effort to open that drawing up and figure out what the report's trying to tell you. Is that what you mean?
Yeah, that's what I mean. I got real excited. I talked about it in the last podcast, having come from CAD P&IDs and going to intelligent P&IDs, I got really excited about the potential. And I was writing reports for all kinds of stuff, oh, look at this, look at this, look at this. But then the consumers of those are engineers, and they're like, it's a graphical draw. I would rather you go mark this on the drawing, right? Yeah. It's yeah, but I'm trying to take a culture of analysis and promote that out to multiple projects, to multiple teams. I want you to take this report and go make those determinations. But it sometimes can fall flat because the receiver of that is trying to translate a relatively boring data grid into action that they have to take. That may not be obvious action or whatever. And I don't know. I just felt like, unfortunately, there was it's like a signal that you send out. It just kind of slowly fades away. You have a few people that are close enough to the idea, and they receive that and they get excited about it. But a lot of people say, I'm not sure I'm ready to chase those things down. You're going to have to do more work to do that. And I found it hard to get the connection with the users. So, I'm sure you've had some folks that you've worked with where you had some quality control reporting or some engineering checks, and they were ready to receive it, and they were really interested in it, and others that it kind of missed the mark. Is that right?
Yeah, it depends on how invested they are in helping you write those reports too. Sometimes, if you come to someone with a report that you think is cool, they might not be as interested in it as you from a data perspective. But if they're coming to you with their problems and you're helping them solve them, then they have that ownership, right?
Yeah.
They feel more inclined to go and tackle the problems than if you come to them with something that you think is an issue, like in Smart Plant P&ID, if things aren't laid out a certain way in the drawing, but visually it looks okay. If someone's just a PDF consumer of those drawings, they might not care what it looks like in Smart Plant if it looks fine when you print it out.
Okay, I'm glad you brought that up, because if you're trying to generate, and I think the line list is the one thing where it has a from to functionality, where you're trying to not only get the fact that pipe exists and its properties, but you're trying to tell a story about that pipe. A lot of times this concept where kind of people pushed about to a point of stopping is, how far do I go with automatically interpreting line routing and its function? And that is an area where there's more opportunity, and I'm glad you brought that up. It's okay, the drawing looks pretty good, and I can issue it, and we can probably buy and construct off of this drawing, but I can't get quite the story off of it yet. I'd like you to go adjust your drawing a little bit. And that's kind of where I was describing earlier, where we got to a value proposition point where you kind of get to a point of diminishing returns unless you have a consumer really vigorously wanting that final result. If everybody's final result is a drawing that looks pretty good, you kind of stop and you say, I'm not going to go ask the drafting team to improve that a little bit more so that I can get my calculation better out of it. I'll just kind of fix it, post drawing. I'll fix it on the way out, and we'll settle. I feel like there's been a lot of settling at that point, and I think the interaction I'm describing with the consumers of the reports is related to that too, because you write some reports, they're well received, and you'd love for there to be more engagement, but you kind of settle on the basics and you don't push the envelope and say, hey, let's go deeper into these graphic connections. Let's go deeper into the way that we can study our project.
Yeah.
And so I know that I needed a better way to further that conversation. And so a lot of my experience, and I'm reflecting back to on projects, goes back to about 10 years ago, where I got to a point with the smart P&IDs where I wasn't quite sure of the next step, because the audience that I had was okay, but the engagement I wanted to be more, and I've been kind of searching for a way to show that. And one of the reasons that we're doing this today, is going to show a little bit of this graph visualization, is because I think it can help with that conversation. It can help with people receiving the data and being more interested in it. It can shorten their time to actually process what that change is or what that finding is, and maybe then eventually be a better way to interact with the drawing, because there are also scenarios where, let's say you're talking about process information, you might go to the drawing, extract a list of lines, and then hand it to a process engineer and say, hey, I want you to enter all the process data for these lines. Well, they have to look at the drawing, look at the spreadsheet, type in their data, look at the drawing, look at the spreadsheet, align the two. That's pretty inefficient. And so finding ways to connect those two into one is really the key. So Grace, you've helped us recently, taken over some of the work we're doing with this visualization. And we have a relational database is the source, right? And we're representing that how?
In a graph visualization.
Okay, a graph visualization of, let me see if I can get these terms right, nodes and edges.
Right.
Right?
Yeah.
So what are the nodes when we look at P&ID? And I'm going to say, Danielle, if you can go ahead and share. This is also a really important podcast for us. We've done this straight up, just people talking. Yeah, that's okay. We've done the whiteboard, which is a challenge, I got to be honest, with the lighting and everything. We really haven't done one with like a graphic inset. So we're proving that we can figure that technology out. So if everyone who's listening know that this is a groundbreaking Prolytics podcast or In the Loop podcast, because we're gonna bring this in and we're gonna try to make it more interesting than a Teams meeting. So Grace, I've got a graph shown here where the background is fully transparent, and we're just looking at the nodes and edges of this graph visualization. So as you're pulling the data out from a relational database, what becomes the nodes and the edges of this thing?
So the nodes are like the symbols and like anything that's basically not aligned on the P&ID is a node. Anything that is aligned is an edge. So I'm trying to represent the graph as the P&ID as close as I can.
Right, because in terms of a graph visualization, you've got the core idea of like you said, nodes. They could be represented arbitrarily, right? They're just a connection point between multiple objects. And so when you say the lines, you mean on a P&ID, they're piping lines, but there are also electrical lines, there are pneumatic lines. So anything that is a wire or a tube or a pipe essentially is a connector.
Right.
Is that right? Okay. And then the nodes, Ted, there we're talking about valves.
Yeah, piping valves, equipment, instruments, all that kind of stuff. Even the pipe runs themselves are kind of dual role there. The pipe run is sort of its own object, like the line number from your line list, but it also connects to things together. So it's also a little bit of a node. It's
Okay, yeah, because I was thinking that, like, as you were describing that, and I was regurgitating it, I was thinking, but wait a minute, we draw a node for the pipe.
Yeah, so the pipe has properties and is a node, and then it's connected in between other objects. You could have a valve, and then a little relationship between that valve and the pipe, and then a relationship between the pipe and a nozzle that's related to equipment, and you just go down the chain of things in your drawing.
Okay, because we're using a test drawing here, and I'm going to show the example P&ID here is, I can do the node size. There we go. Okay, so we have a simple drawing here with a line, a couple of valves, a control valve, and a vessel, right? And so what we're saying is a lot of times where the smart P&ID concept kind of stops is somebody uses it to pull a list of all of those valves. There's some calculation there to make sure they get the right part number and all that. But essentially pull a list of the valves, a list of the pipe, a list of the instruments, and that's it. So you have the drawing and you have these lists. And therein lies that so what conversation, right?
Yeah.
But the truth is that all of those guys are connected. And if I hide this background image, so we can represent the same thing that's in that actual engineering content in more simple nodes and edges. And that gives us the opportunity then to analyze it and visualize it in a different way. So where do you see, Ted, some of the usages? I mean, like, well, real quick, I mean, like this vessel here is an obvious node with nozzles that go around it. And inherently in the relational database, when this was drawn, those nozzles were associated with that vessel, and their connection is something you can navigate. We've got piping that comes in from the left into this vessel, into a nozzle. We've got piping that leaves to a relief valve, and we've actually chosen to represent this in the layout of the drawing. So, like, I was transparently adjusting the graphic behind the graph here, and we could show this graph in other forms where it's not necessarily tied to this footprint. But I think what we're kind of seeing is that for our consumers, they're still most familiar with this canvas.
Yeah.
And so it feels like it's good to anchor our graph to that canvas. But what have you heard in terms of, or seeing in terms of the value proposition with this?
Yeah, so I think, like you're saying, the original lists that people are exporting, like valve lists, line lists, and things like that, usually maybe show the relationship like one layer deep. So you want to know what pipe a valve is connected to. So you might have a line number in your material takeoff for valves or control valves. But it's harder to go further down the relationship chain and find, like, what is the piece of equipment that this control valve is, directly affecting, or for PSVs and relief devices.
What is it protecting,
What
right?
is it protecting? And that there could be like 5 or 6 different piping components in the way before you get to that piece of equipment.
Okay.
So traditional SQL queries struggle with, having an unknown number of steps to reach a result.
Right. Even like I look here on the right-hand side of this graph, we have a level gauge, and that level gauge has a couple of tubing lines to connect to it. So even if you wanted to say, just from a reporting standpoint, you wanted to say, hey, I want to know what vessel that gauge is attached to.
Yeah.
Well, truthfully, I've got to work through 5 or 6 different relationships. I've got to go through the tubing, through the nozzles, to get to the vessel to say, hey, that's a level gauge on this vessel. Obviously, that information's there, but if you're just writing a database query for that is a challenging query. I mean, behind the scenes here, when we look at this particular Smart P&ID package, I would say that, the objects that an engineer is aware of, the tagged items, which are valves, instruments, pipe. Those are actually maybe just like 40% of the real data that has to be stored in order to manage the entire drawing. Because in order to manage the drawing, I have to know every object and then everything it relates to, and then obviously the layout of those things and how they fit together. And so a lot of the reporting, I believe, has been done on that 40%, the easy 40%, which are the obvious things that engineers know about. But even just a relationship through a little bit of tubing and a few nozzles to get to a piece of equipment is not the easiest thing in the world. Is that fair?
Yeah, that's fair.
Now, a valve, if I drop a valve into a line, it has an inherent relationship with the line, like directly, to where from the software, it's easy to determine that line belongs to that, or that valve belongs to that line. But it is harder to know, like you said, if I want to go through several items downstream to get to the next piece of equipment, it's much harder to do that purely from a relational database standpoint.
Yep. And you can ask graphs like simple things, like if you had a control valve with some reducers and then some block valves outside of it that were tagged piping valves, you could say what are the piping valves that are blocking this control valves that I can go do work on it. So if you needed to write a work order against that valve, you could use the graph database to help you figure out what other valves you need to actuate in order to block the flow from that valve and go perform work on it and things like that.
Okay, like isolation planning is becoming a topic here. Yeah. Okay, I think also everyone's trying to figure out how to apply AI to engineering scenarios, and the truth is, reading a P&ID, like a graphical P&ID, and understanding it, certainly it's not impossible. But most of the AI models I've seen, if you're just giving it the picture, understanding the actual crossing of lines, understanding the spatial relationships, if something's floating, like on this graph that we're showing here, this yellow object is an alarm note off of a process controller, a pressure controller. And so the association of that object to that, there is a relationship in the database, but in a printout, you just have to find that text and then process what object it's closest to, which on a simple drawing like this maybe isn't that big a deal, but I have not seen good success on a more complex drawing being able to associate these auxiliary objects to their parent.
Yeah.
Is that fair?
Absolutely.
I mean, you recently did some testing with AI in terms of trying to do some systemizing on P&IDs and detect flow and color. Even, I mean, there are struggles interpreting the graphics of a complex engineering document, right?
Yeah.
And so the one of the ideas here is that being able to put this data together into a graph data set, not only the visual, but just the data set itself, and eventually into a graph database. Because right now, we're going directly to this graph, straight from a relational query into this graph. Is that correct?
Right.
And then we have the ability to transfer that into a graph database if we really need to store it there. But in the interim, the idea is to maximize the value we can get directly with the least number of steps in the way and see how far we can go with this. But I think then in that graph format, we expect that to be friendlier from an AI perspective to be able to do some of this traversing, right? Rather than asking AI to look at a picture and say, hey, how do I go out from this vessel to my nearest block valve?
Yeah.
Instead of trying to do that visually, you can do that through the relationships, right?
Yeah, because you would name your edges to be more like semantic. So you could say is upstream of, if a valve is upstream of something, further down like a nozzle, or you could say is sensing. If you've got a temperature element sensing temperature, you could say the temperature element is sensing temperature in this pipe. And then AI generally is large language models, so they're more, tuned to be able to ask semantic questions rather than try and write database queries that are joining foreign keys and doing all sorts of crazy stuff. Mm-hmm. The graph setup is more intuitive and semantic in nature, and so you can ask more natural language questions to it and get answers.
Okay. I know I always had trouble when I was trying to do this purely in SQL, especially when something branched.
Yeah.
It was like, okay, I can go from one thing to the next, but when that next thing goes three different directions, how do I represent that in a way where I can hand it to an engineer and it makes sense to them?
Yeah.
And I never really got to a point where I thought that was excellent. I mean, in your line list work where you were trying to develop the from to from the line list, that had some challenges in terms of final delivery too, I guess, right?
Yeah, yeah. So some of those specific challenges are conquered by the type of relationship that's stored in the database. So you can tell if when pipes are branching off of other ones, there's a branch type connection there, versus, if they're truly teeing off of each other, one's going to a vessel
Okay.
and one's going somewhere else. But
Well,
yeah,
right. And in this graph we're looking at here, we actually have an example of like the software knows when a pipe is connecting to a valve and when a pipe is connecting to a nozzle or when an instrument is connecting back to a control system. So like in this case, we're using a dashed line to indicate an electrical connection from from a PLC to a valve, whereas we're using a solid line to indicate a connection between piping. But you have that, all of that is spelled out in the relationships. What are the objects that are butting together, and how are they supposed to act when they come together?
yeah,
Right? Okay. Now, one of the things that I've been really passionate about here recently is I had someone who was attempting to do this, and they said, "Hey, I don't. The data is not there for us to draw a graph." And I thought, wait a minute, I think you must be looking at it wrong. I can literally take this drawing and delete it, and then I can go to the database and say, hey, redraw that whole drawing, all the rules, all the consistency checks, everything. And the software, the native Smart P&ID software, is able to redraw the whole drawing. So surely we have the components needed to depict it as a graph because it basically is a graph.
yeah,
And so we recently have gone through kind of an additional push to make sure to prove that, because we had people saying, I'm going to switch to a whole different software because this one doesn't have the intelligence I need. And I thought, well, that's weird, because I think it's been there the whole time. It just hasn't actually been used that much because of the business problem we were talking about earlier. Was everybody's first goal was just getting a drawing, and there wasn't a loud enough voice in the room to voice support to get that additional relationship data. And so it was more of a kind of just like a victim of just not having the right need. And it went on for so long that people are like, yeah, this is just a way to draw good drawings and get lists out, that people stopped pushing the envelope on what could come out of it. So I'm very interested in that scenario there, and trying. I think this is all kind of reviving for me. It is reviving the idea that there's a lot of power. There wasn't the right way to deliver it.
yeah,
Right. And I think to be fair, I think the concept of graph visualization is just hasn't been that prevalent, at least in the engineering industry. Like you said, you guys studied that in your coursework. What did you study about the graph concept in your coursework?
We studied like what a graph is, and then nodes and the edges, and the different algorithms you can use on graphs, and the different structures that a graph can have.
So what was the go-to data set? Were they generally going to people like LinkedIn graphs, or what was from an academic standpoint? And that maybe there's no answer. I'm just kind of curious, because I doubt it was probably equipment and nozzles.
Right. It would. I mean, yeah. I mean, you can think of it like people on LinkedIn, or like we had animals, or maybe like parts of a company, or like
Yeah.
a city, like just like basic examples, just to put it in perspective.
yeah.
Okay.
Neo4j's example is movies, so it's like actors and directors and who was
6
in,
Degrees of Kevin
exactly,
Bacon.
who was in this movie together, who acted in Toy
that-
Story with Tom Hanks.
That here's one of those references. I mean, you do know that reference, right?
Yeah.
Do you know the 6 Degrees of Kevin Bacon?
No, I don't.
God, it's died. That was the go-to relationship explaining
Yeah.
concept. But the theory there was a time, like I turned on A Few Good Men yesterday, and Kevin Bacon's in that movie with Tom Cruise, and so you can. But the theory was that every actor is 6 or less movies away or connections away from
Oh,
Kevin
I
Bacon.
see.
So you could depict that in a graph database. And yeah, when I go to the internet and ask for some type of graph data discussion, it's always generally about people.
Yeah.
But that hasn't been a prevalent discussion in terms of engineering objects and topics. But it's a perfect discussion, I think, for a piping network. It's also really good, I think, for cables and wires, and that's something that we're also working on is how this could be used in that concept of mapping out a facility there from an electrical standpoint. Yeah, it's the graph concept, which is one of the you never know when a buzzword is going to land, right? Some buzzwords pop up and they fade away, right? And so whenever they kind of show up on the scene, now I guess our guy Chad is telling us that he's been doing graph databases since he was a wee lad in his academic career, and he's done them for 30 years. But whatever, he didn't bring that up when we showed him a P&ID, right?
Right.
10 years ago. So anyway, it's relatively new, and I think it's a powerful complement to the data set that we're working with. So that's why I'm excited about it. So it took something like that, I guess, to get other engineers to look at it and say, oh, well, that is better than just a drawing with lists. Now, I do think I could build upon that. And then we also have clients talking about the concept of a graph of graphs. So this graph is a starting point, and then you offshoot from that into other graphs. I did want to show, we have an option here to show the the whole plant. All right, I'm already on it. Okay, plant graph. And so this is now showing where we're working on one graphic, and then we swapped over, and in P&ID it's another page, and we talked about that. Like, is there a future where we break free from the borders and we say, hey, this is a model of my entire plant. It's not one drawing, because there's cost to that. Every drawing has cost around the management of it, the reviews, the revisions. Is there a way to make this more seamless, right? And kind of compare that to the 3D model, where the 3D model is really one big picture of your plant. The P&ID has always been arbitrarily broken up into digestible chunks, and then that creates a bit of a challenge. So if we zoom out, we're able to see kind of 3 drawings that we're going across here. And in fact, I guess, Grace, you put in some filters, for example, where there's an off-page connector here that's purely built to just connect those 2 pages, all right? Information leaves one, it goes to the other. Well, we have to have a departure and we have to have an arrival, and those are not necessarily drawing 1 to drawing 2, right? It could be drawing 1 to drawing 10, and you have off-page connectors going everywhere. So like one option here in the graph world is to turn off the OPC, and now we just connect the dots from one valve or one line to another line, which I think has some potential when you're talking about, I want to peel away some layers. I've got a lot of extra data here, but maybe I really just need to be focused on piping and equipment.
Right.
And is that going to help me, or block valves, so that I can worry about the isolation? And some of those smaller items can be hidden away. Now, how does the graph handle that when you just drop out? Because that's a necessary, like if you're looking at this as a list of relationships, it might take 50 relationships and you traverse all of those to draw the picture. But then if I just hide a handful in the middle, it just kind of bridges the gap. Huh? How does that work? Do you know?
Yeah, so the graph has a list of nodes and then a list of edges. And it also labels the nodes. So when you deselect an OPC, it basically finds the 2 nodes that are on either side of it, and then it changes the target from one end to the source of another. So it basically just makes that hop by changing the source and the target of that single edge.
Okay, and some of that intelligence is in the control that we're using. The graph object here, this what's the development? This angular
It's a
graph
component. Yeah,
component
that's
that
what
we're
they would
using.
call it. Yeah, and I mean that only really makes sense in certain cases, right?
Right, there's some
Flow.
things that I could turn off and it just kind of makes a mess.
Yeah, flow from one object to another is one where you could take a node out and be safe there, but different types of relationships might not behave nicely if you're taking out those middle components.
Yeah, like a valve, generally, most of the valves we deal with are two-way valves.
Yeah.
So I can hide the valve here, and basically the graph just goes from line into instruments and equipment, and it hides the piping valves.
Yeah.
Right? That's one way to do it. Now so we're about at time for this discussion today. So we wanted to introduce the fact that number one, I think, and I can't speak for all of the different. I mean, there are different levels of sophistication in the CAD packages. Like if you tried to take a normal AutoCAD drawing and say, "Hey, I just want to read this graph exactly from it," I don't think that's going to work very well because I don't believe the relationships are in there. Now, we could have some people listening who have developed a really complex CAD arrangement and they believe that may be true. And I would say, great, let's talk about it. And then you kind of move up the sophistication chain, and there are other packages that are out there. I can't speak to the success of all of them, but I can say, like from an Octave smart P&ID perspective, we feel really good about the level of data that's coming out and the connectivity with the graph. I think this has the potential to unlock a pursuit to even improve the drafting a little bit itself, to improve the end final product to where all of those routes are properly documented. All of the connections are really good, because like you said, sometimes you can draw it in a way that's kind of technically right, but not ideal for the relationships.
Yeah.
Right?
Sometimes you have little stubs of pipe that you don't put a flow direction arrow on, and then the software doesn't get the right flow for that segment. And when you print it out on paper, it looks okay and you can understand it because you know what you're looking at. But in the background, things like flow direction might be backwards or not defined. And so when you put that in the graph format, all of a sudden you don't get those nice, like this flows into this kind of relationship. And so that would be a reason to prompt your drafter to go back and assign the correct flow to that item, for example. That makes sense.
Okay. Yeah, exactly. And to go back and prompt that drafter, like I was saying earlier, needs an ROI. It needs a reason to do that, not just because, hey, the data person wants it to be perfect, right? Because you deal with that, like the cost of perfection. You have to have a value prop for making that change, which graphically won't change the drawing. It won't change the person in the field who's trying to look at it and make a determination, but it can affect the data, which if you have a consumer, a partner in this equation, then that value can mean something to them. So
yeah, and I think that value comes in the more advanced uses of the P&ID. So like you were saying earlier, isolation planning, HAZOP, things like that, where you're really having an engineer read the P&ID and understand the relationships. You can get a head start on some of that by having the relationships built into how you draft the drawing.
Yeah, I think that idea of an automated HAZOP, and which is hazardous operations evaluation.
Yeah,
I think that's really important. I wanted to show one thing here. Are we still sharing, Danielle? Okay, great. So this is a different format of the graph database. COS, I had it yesterday. I can't remember the breakdown
something
of it.
Spring expansion.
Yes, there's a spring involved, but you can see the vessel in the middle of these nozzles, which makes sense. You can see the PSV coming off of that guy. You can see the connections to that level gauge we talked about. You can see the pipe that leaves and goes over to the next drawing to this OPC. You can see the control valve and the controller and the little alarm note that we're talking about. So I think there's going to be people that need to see it in this format. There are going to be people that need to see it on the canvas of the P&ID. And it's just it's very interesting to know that the right connections are there in order to make that happen.
Yeah.
Okay, well, that's what we wanted to cover today, is to talk about unlocking the power that I think has been there. It just hasn't been leveraged. And I don't know, I was talking to you about it, Ted, I think it's like, do we have enough evangelists? Do we have enough people like really pushing the thought forward on the value of this? And there isn't necessarily. I know, like in our user forum where we get together, our topics are still relatively normal topics. You know, hey, the way the symbols work, or can I add this data, or can I do that? And getting this extra value out is sometimes hard to get that conversation. And the other thing I wanted to say, one thing is, when you have a product like this, there's generally customization available in your data structure. So I can take an object like a piece of equipment and I can give it extra properties. Company A, company B, company C, they may do things that give it extra properties. And from a reporting perspective, that's a challenge. When you're focused on that 40% of the data, that's the normal tagged items. Well, when your data structure changes, those reports, you have to tweak them. Like, oh, well, company A, we have to use this column and this column, this field. And company B, we have to rearrange that report to do something different.
Yeah.
But I think these relationships we're talking about, these go back to the fundamentals of the way the product was built. Is that correct?
Yeah, they're built into the application, so they're not getting changed. So, ignoring custom fields and things like that, you'll always be able to find relationships between items. And
Okay, right, because the relationship and the connectors that are used, those are not so much up for customization. They are fundamental. Like there is a rules engine that governs how things fit together, and one of our primary experts from our careers. What's the number one rules with the rules engine, Ted?
you don't mess with the rules.
Don't mess with the rules, right? So they do stay mostly intact. Some people mess with them a little bit, but they stay mostly intact. And I think it's important. A lot of people, we've talked about handover and we've talked about administration and standardization and all that sort of stuff. Blake and I have through a lot of these podcasts. And a lot of our messaging there is you got to watch out for customization. Because it's true, as you're trying to fit all this back into your organization, that customization has a cost. But I think fundamentally what we're showing here, these connections, are some of the fundamental connections of the software, and they don't necessarily get affected as much by the cosmetic adjustments to the metadata properties as you may think. So I think this is ready for use for people that have that data set to start with. So, okay, good. Well, thank you guys for joining me in the discussion. I'm having a good time in the office. People are, they're kind of saying, "Hey, settle down on this graph stuff, buddy. It's a little much." I'm like, well, I'm enjoying it because I like the visualization, particularly around communicating back to the engineer that, hey, look, we found something. Check it out. And their ability to see it more natively to the way they want to see it. So, okay, great. Well, thank you guys for joining us on this podcast about smart P&IDs and graph data, and we'll see you next time.